about 3/4 of the students. The reason why everyone hates us is because of this here, well, this plus a little bit of this. In order for the students to be able to go on to apply for the professional courses, they have to get at least a B in chemistry. And whilst lots of people pass chemistry, not many of them get more than a B. A lot of students do very well, but an awful lot don't get a B. And so that's this chemistry is traditionally the paper that stuffs them up. So that's why everyone hates us. And they go off into anatomy or something. So that's this year's marks, and that's about typical. Okay, I should also say our pass rate is much lower than all the other first-year health science papers, because we're harder, I suppose. Okay, the other paper in the second semester, the much sort of friendlier one. So Chem 191 is largely a service paper, and it has kind of a love-hate relationship within the department. People see it as being important for the department, but also it's not really what we're about, because it's kind of targeted at students by and large who are not chemistry majors. The paper which everyone likes more is Chem 111, which is the second semester. Traditionally it's called Molecular Architecture. We're going to have to change the name of that sometime. It's a much smaller class. It only has about 120, 130 students. And these typically are the ones who are physical science majors or chemistry majors. So these are the ones who actually did chemistry at school, liked it at school, suffered their way through to 191, where they do boring labs and lots of lectures, and it's biology and they don't see the relevance. And they come to this paper and they realise again why they quite like the chemistry at school. So we have 44 lectures. The lecture load's about the same. We have labs every week. Some of them, it's 8 labs, but those labs are, some of them are 2 or 3 week labs now. And we have weekly tutorials for that. So it's a lot smaller, it's a lot friendlier, it's a lot more one-on-one, and they get a lot more out of it, I think. The course kind of complements 191 in terms of the material we cover, so all the stuff that wasn't in 191 we teach in 111. So there's a module on states of matter, where we talk about gas laws, intermolecular forces and that sort of stuff. Then a big section on science structure and bonding, so stuff about structure of the atom and emission spectra, and a little bit of quantum mechanics as an introduction to that. And then bonding all the way through to, these days, heteronuclear diatomics. And the lecturer who teaches that is Henrik is very big on computational chemistry, so increasingly there's little smatterings of computational chemistry and Spartan type stuff working its way into this course as well. Then there's a small module on stereochemistry, and then a big part on spectroscopic methods for molecular analysis. So we talk about IR, NMR, mass spec, and IR, NMR, UV as tools for analysing the structure of molecules. So this is very much sort of hands-on. This is how this technique can help you work out what this molecule looks like. Not so much about the theory, that's for later on, but very much using these things as a tool for understanding structure. And then finally there's a little module on colloids at the end, which to an extent kind of wraps up a lot of the ideas that have come in the various modules beforehand, a bit of physical chemistry, intermolecular forces, bonding, talking about colloids specifically in the context of using them for water treatment. And as a part of that, this year we started, we had a field trip up to the water treatment station up at Mount Grant in Dunedin. So it took some of the students who were keen to go up and have a look and see it all actually happening. These are the labs. I won't dwell on these too much because Dave's going to talk about the labs in more detail and talk later on this morning. But obviously there's 8 labs, but they were over 11 or 12 weeks, so some of these labs are multi-week jobs. The assessment is just a mixture of a final exam and the labs. Traditionally the labs have been all exit tests, as it was the case with 191, but this year we brought in lab reports. Dave's going to talk about more of this as well, but a lot more emphasis on lab reports and trying to get the kids actually showing that they understand what we're doing, rather than just memorising what they feel they have to answer some multi-choice questions. And then this is the statistics for the paper. Obviously they were a little bit better than 191 because partly we've already got rid of all the core students, but also because these students actually really want to be there and they know chemistry and they like it. So quite a lot of A's and B's. So that's my 3-second summary of what we did in first year. Issues for first year chemistry. A lot of the stuff that we have, problems that I have to deal with is sort of coordinated 191 revolve around the first 2 things. okay, and especially the first one, which is that the class that we get is a very, very wide range of chemistry backgrounds. As I say, Otago is very good at marketing itself everywhere, not even just in New Zealand. And so we get an awful lot of students come here to do first year health science. There are about 11 or 1,200 students just to come here to do first year health science, competing for 250, 300 places in professional courses. So a lot of the students who come here never have a show. And part of that is because they haven't done the stuff at school that they need to do. They haven't done chemistry at level 3. In many cases, they haven't done chemistry at level 2. And they haven't done the math. And so this makes it really hard for us to know where to pitch the course. There's an implication, there's kind of a requirement from the first year health sciences. There's all these levels of committees and stuff that I'm on, and there's all these stakeholder departments. And they all kind of have an expectation that we're going to do this and this and this because they want their students who are going to do medicine to do this and this and this. But of course the students who actually end up doing medicine are just a fraction of the class. And we have to be thinking a bit bigger than that. So there's this kind of this issue that we have to try and work for it. And I think in reality we probably try and teach more the middle of the road, perhaps traditionally slightly below the middle of the class. The hot topics were designed, I think, as being a way to sort of meet the needs of the smarter kids, the ones who are going to go on to do medicine and dentistry and try and keep their attention. But